Hello, everyone. My name is Kannan Muthukkaruppan. Love to welcome you all to today's YugabyteDB Friday Tech Talk series. And this is for engineers, by engineers. I'm one of the co-founders at YugabyteDB, and it is my pleasure to welcome Frits Hoogland to today's talk. Frits, I know this is not your first time on this series, but it would still be great if you could introduce yourself and then get started with the topic.
Yep, my name is Frits Hoogland. I'm Dutch, and that is why the name is so pronounced so weird for most English-speaking people. And I'm a developer advocate with Yugabyte for over 2 years now. And I love to look into technical topics, and the topic I will be talking about today is the auto-explain functionality for Postgres and YSQL. So let's get started. To answer why you would want to use auto-explain, the first thing you need to understand is what is explain in the first place. And explain means to let the Postgres engine show the execution plan for the statement that is being submitted. And normally that would be done by using the explain command, such as on the screen, which says explain select star from T. I created a T table. The T table isn't there by default. And then it tells us that this is performed using a sequential scan on the table T. So explain shows the plan, and this is a very simple plan, together with something which is called a cost assumption from the planner. That is a estimate from the cost is an estimate from the planner, but that is what the planner actually uses to create the plan. If you want to see the runtime statistics, which also means that you then actually have to run the statement, because explain without analyze doesn't execute the SQL, it just generates the plan and then shows the plan. But for the runtime statistics, you can execute it, you can plan it and execute it, and that can be done in this in the CLI itself using explain analyze. If you perform explain analyze, then it shows you the cost again, which we just seen, but also the actual time. Yep, the actual time here, which is the time spent in each plan line.
Maybe you can finish the slide. I had a question on it, Frits, but go ahead.
Along with the explain, it also tells the planning time and the execution time and the memory usage. And the memory usage part is unique to YSQL. That is not visible in auto-explain, which we'll see in a little while, which is where this talk is truly about. So
yes, on the previous slide, Frits, I was just curious because I forget the details. So because explain analyze actually runs your statement. If this was not a query, but if it was suppose a update statement or an insert statement, does the effects actually happen, or does it run it and roll it back?
Oh, that is a good question, because I always swap the delete or update with a select to just run it, because then you just have to modify a little bit to do that. So I always do that to be ultra safe. So I even haven't tried it.
Okay, so that's a to-do exercise for both of us to figure out.
Yeah. Especially if you're in an environment that you don't understand. I'm ultra safe with these kind of things, so I never do that. Okay, that was the explain part, and now the auto-explain part. What is auto-explain? Well, in the light of Yugabyte, it's specifically YSQL, so the Postgres API functionality. And it allows you to perform the explain part for SQL statements completely automatic. In order to do that, it uses what is called a module or a contrib module. And that module is a library, and that library has to be explicitly loaded with the Postgres parameter shared preload libraries, which then additionally loads this library, and the library then internally uses hooks so it can be included in every execution. Another part which is really important to understand is, because this is a T-server flag, it means it's local to an individual T-server. So if you're using a Yugabyte anywhere and you set it, then it will be done automatically for all tablet servers, and it will be done everywhere. But if you do this manually by hand, by manually setting the YSQL pgconf CSV G flag, then you explicitly need to do it for each individual tablet server.
And you use the term module, but is it fair to say that some people refer to it as just an extension? It's a Postgres extension. It works with Postgres, and because we are highly Postgres compatible, it works with Yugabyte as well. Yes,
yes. I believe module, contrib module, and extension are all used interchangeably. That multiple people, and also the documentation sometimes talk about extensions and sometimes about modules. So indeed, would be better if they use a single statement for it, so there is no confusion, but that's not the case. When it performs the explain, it logs the output to the Postgres server log file. So in the Postgres situation, that is the Postgres server log file. In the case of YSQL, it's also the Postgres server log file, but then of the specific Postgres instance that you have logged on to, and it shows that. Got it. So
every node in the cluster has a Postgres log file for statements that it's handling, and it'll be in the corresponding log file. This obviously raises one question, that if you're if by using auto explain module, if you're going to automatically explain SQL statements that are being executed, will there be like a lot of performance overhead, or is there a way to control some of the frequency of so maybe you are covering that later in the talk.
Yeah, I will be covering that, because there is some impact which you should be aware of, and I would even doubt if you want to include this in production. And I think it's also style, because a lot of UIs provide explain functionality quite close in the UI and easy to do. So it's what you're used to, whether this extension or module is actually that handy. But there are also situations where this is really extremely handy. And I get to that too. Well, it's actually the last statement on this list. But if you add the auto explain library module extension to the G flag, which sets it for the Postgres instance, then the functionality is available. But once it is actually available in your instance, in your Postgres instance, it's still disabled by default, because the library adds a flag, autoexplain.logmin duration equals -1. And of course, something cannot have a duration of -1, and therefore this means it's disabled. So it's then available, but it doesn't do anything. Now, the first thing you can set it to is 0. So a duration of 0 as min duration means all statements are explained. And as I put here, as an answer to your question too, this can cause performance issues. Not so much because of the explaining, that probably doesn't give that much overhead, but it's the synchronization of all the different sessions that needs to get access to the log file. That's probably the biggest overhead here, because if this would not be synchronized, then you would get multiple explanations being mixed together, which wouldn't make sense. So this is synchronized, and that's probably what causes most of the issues. If you set it to a value of higher than 0, then that value is taken as the number of milliseconds as statement latency before, as a threshold, before it actually gets logged with the explanation of the execution plan. And that is quite useful. Then you get only the execution plans of the slower statements. That doesn't mean it's not explained. If you said this, it performs the extra work of explaining on every statement, and only if it crosses the latency threshold, it will actually be written into the file. But like I said previously, probably the overhead of that in most circumstances is quite low. Now, it's written to the main Postgres log file. The main advantage, the main true advantage of auto-explain would be that you can get a hold of statements which would otherwise be hard to find or hard to get. And if you're a developer, you might think that's a bit weird. If I control the software, then I know pretty well what is being executed. Well, I've spent a lot of time in the operational part on doing troubleshooting, and I can tell you that in a lot of situations, things are executed which are not expected by either the operators, DBAs, or even by the developers. So for that reason, it can be really beneficial to have this, to be absolutely sure that you're seeing these statements which are taking a very long time, and get an explain for it too. And getting the explain is really handy, because if the plan can contain parameters which mean that the optimizer chooses a certain path, which might not be the case if you're explaining it yourself. So that is another advantage of using auto-explain.
Yeah, that makes a lot of sense, because often you may not be, it may be a large body of code executing like 8 or 10 sequence of SQL statements. Getting the exact shape of the SQL statement to try it out manually is tedious. This makes it really easy. And you made another important point that sometimes a problem is visible only with a certain input bind variable and not with certain others. So it's like very data sensitive. So this kind of mechanism where, hey, if above a threshold, log more details about the statement and its plan is super helpful.
Yep. So if it's activated, then the earlier select start from T that I showed will show up in the following way. It will tell the duration that it sees, and I will tell something about the duration later on. It will tell the query text, so you can see the actual statement, and the optimizer cost, which made the optimizer choose this execution plan. If you turn log analyze on, which enables explain analyze, it will tell you nearly the same, and it will add the actual timing, like we seen earlier. So this is how it works, and this is what you get. This is, of course, a really simple statement, but I think most people will understand what it means. This is how it's shown. You can set and reset parameters for auto-explain on runtime. If you just set it in your using YSQL SH or PSQL, it's for your own session. You can set it for a database, and then any new session that logs on will pick this up automatically. So you might not need to set it in the parameter file and then reset the entire T server or the Postgres database if you're doing this. However, the scope is always the local tablet server, so the local Postgres instance. It's not and never cluster-wide unless you're bouncing all the T servers at the same time. Then it will be cluster-wide. And there are some ones. So log min duration is the one that we've spoken about earlier. Log analyze enable, if you set it to true, it enables explain analyze. And there are two ones which I picked out of multiple others, which are good to know and to mention. There is log nested statements. Log nested statements by default is off, and that means that if a SQL statement is embedded within PL/SQL, for example, you will not see it because it's not a top-level statement. If you enable log nested statements, it will explain the SQL from out of the PL/SQL PGSQL block. So that is a handy one. And then a sample rate, and sample rate will sample statements and then only show a rate, and so it will not show all the statements. I'm not really sure. Well, you probably need to use it and see if it works for you, because there is of course a chance that it will sample the statements, just the ones you didn't want, and does not sample the ones you want, because it picks out on random certain statements. But if it works for you, then it's fine, of course.
So maybe you mentioned it, Frits, but so with the sample rate approach, probably in a very high volume system, maybe then it doesn't, it only does the hard work on that percentage of requests, right? Like suppose I set my sample rate to 1%, then presumably it flips a coin at the beginning, and then only on 1% of the statements it actually does the work of analyzing or explaining.
I don't believe it works that way, but again, I've never used it because of disliking it, that it can pick the wrong statement.
Got it. So you don't use the sampling feature?
No,
because yeah, sampling by statement count has a bias that if there are millions of short running statements and then one like statement that really runs for an hour, it treats all of them equally.
Yeah, but there are a lot of caveats of sampling, and that is why I don't like it, and I like to be very precise and exact in these kind of things. And the chances of just missing it or missing it entirely are just so high. I can see it if you have an application which creates hundreds of unique statements, that this is gold, because you just need to pick out a few to see what it does. But in a lot of cases where I think we both work in a lot, that something specific isn't working, it doesn't help at all for that. And that is the things that I see a lot. So therefore I have never used it. And that's why I said, if it works for you, if you like it, fine, use it. But otherwise, there might be caveats and you might just miss the important thing.
Yeah, fair enough.
And there are some other parameters with how to explain which do not apply to YugabyteDB at all, such as log wall, because we don't use the Postgres wall at all. So there are some more. Having said that, and hopefully you've made a mental picture of what how to explain looked like. There is something which looks eerily equal to how to explain, which is log min duration statement. And one thing is, this is log min duration statement. The overall functionality in that is not an extension, that is just built in Postgres hard. So it's always there. It's also disabled by default using log min duration statement set to -1. And again, if you set it to 0, then all statements are logged, and it will just log the statements. And if you set it to a value greater than 0, it is taken as the number of milliseconds before a statement gets logged. And it's also written to the main Postgres log file. This functionality is what MySQL people will know as the slow query log. So you can just set it to a certain amount of milliseconds, and anything which gets logged by log min duration statement, therefore will be a slow statement. So it's easy functionality. Of course, this doesn't explain, it will just log the statement itself. And this is how that looks like. The above here is, I now took sleep 1 for a select statement, is the explanation. Query text is select pg sleep 1, and result is the execution, which is just result. And log min duration statement will say statement select pg sleep 1 and a duration. The thing I want to highlight, and this is one thing, especially if you're a performance engineer, which is really interesting, is the difference in duration. Sleep 1 will sleep, so the statement will take 1 second, and this duration is just over 1 second, 1 millisecond. And log min duration statement says that the duration is 20 milliseconds over 1 second for PG sleep. So why are these durations? And because the naming is identical, you would assume that it's showing the same value. And that isn't true. And one way in which you can see that is if you execute this query using the extended query protocol, then auto-explain will essentially just show the same. It's a duration of just over 1 second, and it will show you a result in the query text. However, log min duration statement now gives kind of a hint, and that is the extended query protocol has 3 phases in which it executes something. The first one is pass, then bind, and then execute. If you look at the execute one, you'll see that these are pretty alike. And actually, auto-explain is a little, so log min duration statement is a little higher because that sits on the outside of the execution, and the hook of auto-explain is released earlier, so that will take slightly less time. That's the reason this time is slightly less. But these two are alike, and that means, what this means is that auto-explain only times the duration of the execute part of Postgres execution. In other words, not the latency that a client is actually experiencing. And if you're a performance engineer, then most of the time, the latency that a client is talking about is the database client latency, not a certain part of the execution. And this is actually how that looks like. Postgres has 4 phases of execution: pass, rewrite, plan, and execute. Log statement has duration, takes all of them. If you use log statement with the extended query protocol, then the parse phase that it's exposing in the log file is equal to the Postgres parse and rewrite phases. Bind is the plan phase, and execute obviously is execute. And if you're using auto-explain, then the duration of auto-explain is only the execute phase of the Postgres overall execution. This time is also the time which you will see in pgstat statements. Pgstat statements only as time of a statement only takes the execute time. If you have a Postgres version 12 or higher, it will additionally show the planning time as an additional time. So there you get a better idea that the total time, which is there in pgstat statements of Postgres version 11, the total time is actually the total time of the execute phase, not of the total execution. Now going back, so we've seen the differences and also seen some specifics about the execution of auto-explain, that it's not telling you the full time, but part of the execution, which is the last phase of execution, which is also called execution. For auto-explain, the work of explaining is always performed. It's just what I just said. If the duration is slow, it's not logged, and the overhead is dependent upon a lot of factors, because if your statement is really complex, then the explaining might take more time to do too. If you turn log analyze on, this is actually, if you look at the Postgres documentation, that actually warns you of not turning log analyze on a production system on, which produces a lot of, which executes a lot of statements, because that can have severe impact, because additional to the auto-explaining of the lines, it will also time all the individual row sources in the execution plan, and that can have apparently quite a severe overhead. And I say apparently because I never dared to even do this in a production system because of the explanation and warnings in the documentation. And even if you would do it, then probably the overhead is so environmentally dependent upon the type of CPU, what can be offloaded, how is the server loaded, etc. How do the statements look like in the execution plans? That's impossible to predict what will happen. So that these are the final ones. So there are some warnings for using how to explain. It's not a magical solution which you include as a module or extension and then all your problems are solved. It's an aid on getting more information for execution. So hopefully that was useful and helpful for anyone looking at this and attending and looking at what how to explain does, and more importantly what it doesn't do, and how you should use it or where you shouldn't use it for. I try to show some of all these different areas of how to explain.
Awesome, Frits. And I think you did the presentation in great time, covered a lot of detail and nuances about using this capability. I also shared on the LinkedIn channel some documentation around this module on the YugabyteDB docs site. And yeah, thank you to everyone for joining today's YugabyteDB Friday Tech Talk. I believe next week we are covering a couple of topics related to secondary indexes and JSON-B support for our YSQL API, the API inspired by the Cassandra query language. And these are some extensions that Yugabyte has in its Cassandra capability or in its YSQL capability compared to, for example, Apache Cassandra. So definitely join us. And thank you. So over to you, Frits, as well, for any closing comments or thoughts.
Yeah, thanks everybody for listening in. And if you have any questions, you can go to our Slack channel, which is on the screen. Well, you can see our source code on our GitHub, but also to LinkedIn if you have any questions, or in any other ways. I think we're all probably pretty easy to find to ask any questions or any remarks.
Great. Have a good rest of the day and weekend. See you all next time.
Okay. Thank you. Goodbye.